So we're going to go to another data structure. So we talk about annual report at 10K, right? That's an important data source in accounting and finance. So today we're going to focus on the conference call data. So what's the structure of the conference call data? So firstly, it's important. Many public firms, they host the quarterly conference call, including the executives, investors, analysts. So, and they talk about the financial information. They talk about a lot of stuff. So the format is what? The format is, so before they only analysts can attend. Now everyone can attend. So it's most of the online stream. So available to everyone. And it's normally it's phone call. It's about the phone call. And we have the transcript of the call. So basically, this is the present opportunity to use AI to analyze this transcript. So these are the calls. So what's the structure of the conference call? So first, CEO will make 10 to half an hour minutes, 20 to half an hour minutes presentation. So company will say, okay, the company is doing good, blah, 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 blah. And then after 30 minutes presentation, we'll open the Q&A. And the analyst or investor will ask questions, and the CEO will answer. So back and forth, back and forth. That's the structure of the conference call. That's the structure of conference call. So you can see that. So you can see that this is the Microsoft. So they will say, good afternoon, blah, blah, blah. And then CEO will talk, we to start, blah, blah, blah. And then another executive will say, oh, everyone's good. So all the executives, CEO, CFO, CTO, all the executives will say something to just introduce what's going on with the firm. And then start the Q&A session. And you can see that we'll move on to Q&A. Out of respect of others on the call, we request the participants ask only one question, blah, 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 blah. And then this is an analyst from Morgan Stanley, Kathy. Kathy will say, oh yeah, great session, blah, blah, blah. So you can see that's the structure of the conference call. And then you can see that, so the transcript, you can see who participates. You can see that there's 3 executives participate. You can see which analysts participate. Sometimes there's institutional investors, and then you can see this is NVIDIA, right? So this is the transcript you will get online. This is transcript you can get a voice as well. So what available is the transcript and the voice. That's the data you have. So how we are doing with this data? So what we're doing data is you first to convert this kind of data into this format. So you can see that. So you can tell the company is what? NVIDIA, right? And this is the 2017, and this is Q1, and this is what's the data of the conference call. Who are speaking? This executive speaking. And what's the content of the speech? So number one thing you have to do is to convert this textual data into this kind of structured data, because you have to do that in order to process. So converting from the unstructured data to structured data is either just talking about. This is called number one step, data cleaning and the data passing. So this is the passing. So you passing this unstructured data into structured way, and then you can do all the analysis we did, right? You guys remember? You give the GPT 10 climate sentence. So you have to pass the data into the structured format, and then you feed this to GPT, and GPT will know what's going on. So this is number one step you guys do, data cleaning and data passing to make the unstructured data structured. And then for this one, the dependent parser, it's another interesting point, because everyone uses GPT, everyone uses Llama. Do you know under GPT, under Llama, what's the downside of Llama and GPT is the interpretation of the model. Sometimes you don't know why GPT can do better, why Llama can do better. So another alternative way is what? Is large language model with high interpretability, high interpretation. And I want you guys, encourage you guys to check the video. So I have a video to explain the model, which can explain to you why this text analysis work, why this text does not work. So the good things about the Llama and the GPT is Llama will, give you good performance, but Llama doesn't give you why it work, what feature it work. So this kind of large language model, we say this sometimes is black box. So we have an alternative model which give you really visual features. They can exactly tell you what feature work, what feature don't work. Normally, those models have a lower performance. So basically, the performance is not as good as GPT. But instead, the trade-off, even you have a compromised performance, but you have high visual ability to see which feature work, which feature doesn't work. So the interpretation of the model really work very well. So I want to encourage you guys to look at the video I recorded for you guys, dependent parser. Dependent parser is already part of the large language model, but few people know. You know, the large language model has a lot of sub functions. The large language model have dependency model, large language model have the embedding, large language model. So the large GPT has a lot of other functions. So normal people don't know. So dependent parser is a very important function under large language model. If you use it well, you can have high interpretation. So you can understand why AI work better. So this is something I want you guys to check the video. Why some of the model work, some model doesn't work. So yeah. So basically the idea here is the large language model is a big umbrella. Under the big umbrella large language model, there's very useful functions. For example, dependent parser is a very useful function. Embedding is a useful function. There's many good functions under large language model. So few of you guys know it, but if you understand it by watching the video, you can use the large language model in a way other people don't know how to use. So dependent parser is the way you can calculate the variables. And you can understand which feature work, which feature doesn't work. You will improve the interpretation of the model, while maybe the performance compromise a little bit. But you can check it out. You can check it out.